Hey everyone, welcome to General Psychology. I hope that you enjoy this course. I think this is a great course because you get to kind of taste a little bit of everything the wonderful world of psychology has to offer. I know a lot of you already have taken other psychology classes, so I hope that those combined with this one really give you a nice full experience of what you can get from this field. Some of you I know are taking this class because you're kind of interested in this field and you kind of want to see what there is to offer. We will go through 10 distinct segments in this class. Now, one of the great things about general psychology is that you get to see a lot of what the field has to offer. One of the difficult things about the field of psychology is that you only get a little sip of everything before we kind of move on. So as wonderful and in-depth and amazing as the field of social psychology is, we just spend 1 week on it. So prepare yourself that we're going to be doing things at a very fast pace. Now, I'm having to do this presentation a little bit differently than I normally do because we've had some problems with Blackboard, so just bear with me, please. I know the slides are going to be backwards or be a little funky. I will have the slides available to you through Blackboard, so you'll be able to look at all the slides yourself and go through them at your own pace. I do ask that you don't download and give those to anybody else. Just keep those for the purposes of this class. You can certainly download them for your own use for this class, but please just keep them just for this class. And thank you for bearing with me. Again, I know this is a little funky, but I also know that a lot of you would rather look at something, even if it's maybe a little funny and backwards, than just, hearing a voice with nothing to look at, or just seeing me talk without anything to look at. So that's why we're going to do it this way. I got some IT people who are far smarter than I working on that. Okay, so a little bit about myself. I am Dr. Deborah Bannon. I am a professor here at Matsu College. I am a professional counselor as well, so I see people in a clinical setting. I specialize in seeing children and adolescents, and I am a registered play therapist as well, which means I specialize in utilizing nonverbal methods in order to work with children, a lot who have trauma backgrounds or something else that would make words difficult or hard for them to access, or maybe just not best for them in order to get to what they need to get to. I'm really excited to do this class. I've taught this class several times and I very much love it. I hope you guys love it as well. I'm always open to your feedback and want to hear what you guys love, what you guys would like to see tweaked. And at this point, you are benefiting from a lot of feedback that I've gotten from students. So I hope that you all benefit and enjoy this. If at any point in time I can help you, I want to help you. I am here to assist you however I can assist you. I'm on your side. I want you to succeed. Let me know. I am usually very flexible in due dates and such things if you communicate with me before the due date. I understand life comes up, things happen. I just encourage you, talk to me beforehand. If you ever need an extension, if you're ever confused about an assignment or anything like that, just talk to me. I'm usually available very readily by email or phone. And then if you're in the area, we can even talk in person if you would like as well. But again, don't hesitate to contact me. I want to help you succeed. And then also communication is key. So if something comes up, just let me know. Again, if you ask for an extension the day an assignment is due, the answer is almost always going to be no. But give me a little bit more leeway, communicate with me a little bit earlier, and very, very, very often the answer is yeah, sure, take the time that you need. Again, I want to help you succeed. Okay, so we're going to go ahead and jump into research, and then hopefully maybe we'll get to neuroscience today. If not, we'll have to tackle that next week. Okay, so the three primary research methods. You've got experimental and you've got observational. Experimental and descriptive, sorry about that. So observation is one of the descriptive methods, and then you've got case study and you've got survey. Surveys you guys are all familiar with. We have all taken a survey, right? Please tell me, in the past 12 months, how many times have you smoked, right? Those things are all survey methods. And then you've got observational. So this is maybe you've done a sleep study before where you went to a sleep lab and you were hooked up and they checked your brain waves and saw how your sleep patterns were. That would be an example of some observational research. And then you've got your case study. And case studies are usually one person or one very specific group that is being looked at, is being analyzed to understand better. So an example of a case study might be maybe looking at somebody, Michael Phelps, who's won a whole bunch of gold medals, and looking at him and studying him in depth in order to assess how does a whole bunch of success at a fairly young age impact somebody's later life. So that would be an example of a case study. Case studies can be great because they can go in depth. The weakness of case study is that they may not be super generalizable, right? What may be true of Michael Phelps might not be true of somebody else. Observational is kind of the same. It's got a lot of depth, a lot of good research, but you're observing something happen. There could be, the observer could be observing incorrectly. Maybe they have a bias they're not aware of that's somehow impacting the data that they're getting. And then maybe what they're observing is a fluke. Maybe the way in which somebody is behaving is really different than it normally is. And so that one observation is not super helpful long term. Like that sleep study experiment. You go in for a sleep study, and that has to be the one night that you don't have any sleep disturbances or difficulties, right? Well, some good observational information, but it doesn't help you at all because it's just one night, right? And then surveys. Surveys can get you a lot of information from a lot of different people, are very easy to use, that's why they're used a lot, are fairly cheap, often very generalizable because it's a lot of people. However, it's also usually very shallow, right? You're just kind of skimming the surface, right? I mean, look, there's 3 answers, right? There's 3 options for answers that you can choose to this question that's being used here. That's it, right? That you get 3 choices of your answer, that's it. And a lot of times life's not that simple, right? So surveys have a lot of advantages to them, but one of their downfalls is that they're usually very, very shallow. Okay, so another research method, right, is experimental, right? That would be the other option. So this is the one that is oftentimes talked about when we look at true, or we think of true scientific research. It is important to mention that the other forms that we just visited, these are true scientific. They're very, very much so. In fact, knowing that smoking is bad for you, we know from this research, this kind of research. We do get it at smoking being bad to you from this research too, but we don't have any double-blind studies of smoking being bad from you. So some people that think unless it's a double-blind, it's not true scientific. That's not right. So just remember that there's a lot of different kinds of research. They all have their strengths and weaknesses. So for experimental research, we have an independent variable, oftentimes called the IV, the dependent variable, oftentimes called the DV, and the control variable, sometimes called the CV. So the independent variable is the thing that you're changing, right? This is the thing that you're messing with. The dependent variable is a thing that you're observing. You want to see how it is changed. And then the control variable are things that you keep the same. So, for example, if you want to know how temperature affects people taking a test, what you might do is you might take a class of 50 students who are all taking general psychology, and you would divide them up into 3 rooms. One room is the normal temperature, one room is 20 degrees below the normal temperature, and one room is 20 degrees above the normal temperature. Well, that group that's in the normal temperature room, they're your control, right? They're your control group. The control variable is what you keep the same for all of the groups. So that might be they're all still meeting in the same school that they're all used to. They're all still sitting in the same seats with the same kind of desk, right? So all of those things that are the same for all 3 are the same, and those are all control variables. The group that stays in the same environment becomes the control group. So that's the difference between control group and control variable. The dependent variable, what you observe. So the thing in this experiment you're trying to observe is the grades, right? You're trying to see, does the temperature that they take the test in affect their grades? So the thing that you're looking at is the grades. That is the dependent variable. And then the independent variable is, you got it, the temperature, the thing you're changing. You're changing the temperature. Okay, so these are just a couple little comics I always think are funny. This is an example of naturalistic observation. This would be an example of experimental research, right? Placebo, which means it's at least a blind study. Don't know if it's a double blind because we don't know what the researchers know, but it's at least a blind study. And then here Calvin is taking a survey for Chewing Magazine, and he's going to mess with their data. I like Calvin Hobbes. Okay, so these are scatter plots. Excuse me, we're not going to go into depth a whole bunch on these, these are important when you're really looking at research, but the thing that's important right now is just to understand in general positive and negative correlations. So all correlations are stated to be in between -1 and +1. That's how we think of them. That's how they're listed in research. That's how we compute them. Now, it is important to note, -1 is just as strong of correlation as +1. And both of those would be absolute correlations. Absolute. So a positive correlation would be whenever this thing happens, this thing also happens every single time, without fail, 100%. That's what 1 means. And -1 means whenever this thing happens, this thing does not happen. Absolutely 100% of the time, without fail. Now, very, very, very infrequently do we ever get -1s or +1s. We usually get +0.76, -0.34. Right? We usually get something like that. It's extremely, 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 extremely rare to actually get a -1 or a +1. But it's important to understand that a -1 correlation is just as strong as a +1 correlation. And correlations increase in strength the closer that they approach either -1 or +1. So for instance, let's say you're running an experiment and you have a correlation of -0.76. And you have a positive correlation of 0.54. Well, which one's a stronger correlation? -0.76 is a much stronger correlation than +0.54 because -0.76 is closer to -1. So again, remember, if you can think of the ones, the -1, the +1 as being the ends, as close as they are, whatever number is closer to a 1 is going to be the stronger correlation, whether it's a negative or a positive. It doesn't matter, right? And then again, also remember that a negative correlation means whenever something happens, something else happens. So let's say, okay, a positive correlation would be the number of hours that you study to the grade that you get. When one of those increases, we expect pretty often to see the other one increase, right? A negative correlation might be the number of visits to McDonald's and the health rating score that you get when you visit your physician. As one of those increases, the other one's probably going to decrease, right? The more times you go to McDonald's, the less healthy you will probably be, right? That would be an inverse correlation. So again, this is an important thing, hint, that you'll want to know. Correlation, remember, they get stronger as they approach either 1 or -1. And if you're given two numbers, two correlations, whichever one is stronger, whichever one is closer to 1, whether it be negative or positive, whichever one is closer to 1 is going to be the stronger correlation. There are 3 different ways to measure central tendency. And central tendency is really just kind of a fancy way of saying when you have a whole bunch of data, you have a whole bunch of numbers, you really need a simple way to talk about it. If I have a data set of 2,000 numbers, I can't just list off all 2,000 numbers anytime I want to discuss or explore or do anything with that data. I can't do that. But if I find a way to talk about, well, okay, how do they tend to kind of group themselves? That gives you a meaningful way to talk about them. We call that measures of central tendency. Now, there's 3 measures of central tendency. One of them we're all very familiar with. That's the mean, right? That's when you take all of them, you add them together, and you divide them by however many you have. So if you have 10 numbers, you add them all together, and then you divide them by 10. If you have 15 numbers, you add all 15 together, and then you divide it by 15. And that gives you the mean. The median is when you line all the numbers up from greatest to, from least to greatest, when you line them all up, which one is in the middle? Which one's in the middle? If you have an odd number set, you're fine. You got whichever one's in the middle. If you have an even number, what you often do is you take the 2 in the middle, add them together, and divide them. And then mode. Mode is which number comes up the most. It's the mode. Now, sometimes you can have a bimodal, which means there's more than one common number. So let's say you want to know the mode of the grades for a midterm in your class. And you get all of the grades out, and it turns out that 3 people got 100 and 3 people also got an 82. Well, then that means the mode for that score is bimodal, and it's 100 and 82 are the bimodal numbers of that quiz. Okay, bell curve. Now, for a lot of you, you will not need to really know this. I just kind of want you to be generally familiar with it. It is very cool. A lot of data, not all of it, but a lot of data, tends to fall in this really awesome bell curve shape. It's very helpful. Now, again, not all data does, but most of it does. That's pretty neat. So what this means is that, so here you've got the mean, right? And in a bell curve, a typical bell curve, you have 1%, one standard deviation greater than the median or the mean, and 1% and 1 standard deviation less than the mean comprise 68% of respondents. So, okay, what this means is, let's say that the mean grade in your class for your last quiz was 75 and the standard deviation is 5, okay? So standard deviation is 5, so 75 plus 5, which is 1 standard deviation, is 80. So that would be this. 75 is the mean minus 1 standard deviation, which is 5, which means 70. So that means 68% of the class probably scored between 70 and 80 points. Right? That's what that tells you. These are one other standard deviation, and they tell you the outliers, right? So this would tell you, so this is 1, 2, 3 standard deviations, which in our scenario, standard deviation, 1 standard deviation is 5, so that would be 15 points. So that would take you to 90. So that would mean somebody who scored in very, very much the outlier category got a 90. And then we can do the opposite here and take away 15 points, and we get 60. So that would be somebody here who got 60 points. And they would also be in the far, far outlier category. But again, the majority of that class, if it's a standard bell curve, and the mean was 75, and the standard deviation is 1, the majority of that class would have gotten between 70 and 80 points. 68% of the class would have gotten between 70 and 80 points on that quiz. Okay, these are the, remember I said most curves of the bell curve, or most grades fall within, or most scores fall within the bell curve, but not all of them do. And these are just the right and left skew curves where they don't fall in a normal bell curve. You don't really need to know this, I just kind of want you to know that it exists. Not all data falls in a normal bell curve. We will be talking about the data a little bit in a bell curve. I just want you to know that this exists. Okay. Now, there are a couple things that research can tell us and a couple things that research can't tell us. Something that I unfortunately hear people say sometimes is that research proved that. Well, scientific research isn't about proving something exists. What scientific research is about is proving or disproving the null hypothesis. So you have a hypothesis. Does it confirm or not confirm your hypothesis? All research is taken to indicate something. Hopefully, we hope it's generalizable, right? But true researchers should never speak in terms of proving, just because we understand that we're doing one experiment in one time with one data set. That's very, very different than proving something happened. Now, again, when you have multiple different scientific studies that all indicate the same thing, even though it gets really tempting to say proof, a true researcher still would not say proved. They would say strongly researched, or strongly informed. They would indicate that this seems likely, right? They would say that multiple research experiments have confirmed that or have indicated that, right? But still, we want to be careful with that word proved, because we always want to have a healthy respect for research being wrong, right? Researchers lie. We know it. Data gets corrupted, intentionally or not. So we always want to have that healthy skepticism. Sure, these 10 studies all say this, and that does seem to strongly indicate that this thing happens. However, I know in my mind that that's not the same thing as proving that something happens. So again, it doesn't mean you want to disregard it. I'm not saying that at all. But you want to have that healthy skepticism in your mind. Some of you may remember ClimateGate that happened in, I think, like 2008. A whole bunch of researchers who were putting out data that proved that global warming was happening. It came out that they were falsifying all of their data. They were getting huge grants if they could prove that global warming is happening. Surprise, surprise, the research found that it was happening, and then it later on was found out that they were falsifying all their data. So you had dozens of studies that were all proving something, but the data was all false. So that's just another reason, and that has happened many, many, many times with multiple different things. So you just want to keep in mind, have a healthy skepticism about research, and learn how to read it. Okay, so we're not going to be able to play this game right now. We're going to move on to neuroscience. Okie dokie, neuroscience. Fun stuff, the brain, right? One of the most fun parts about psychology. Okay, so this is a whole bunch of definitions in your textbook, and then a couple of cool videos to watch. I'll make all of this stuff available to you guys so you can read it. These are a couple of terms that you want to make sure you know. I'm not going to bother reading them all on the slide. I'll just say if there are neurons, glial cells, dendrite, cell body, axon, and myelin sheath. These are very important parts of how our brain functions, how our information is transmitted in our brain. Some super interesting research about myelin sheath related to Alzheimer and the breaking down or the thinning of the myelin sheath leading towards Alzheimer's and other things happening. So very interesting stuff. For this class, we won't really get into more than just kind of like the definition of what it is and the very, very, very most basic understanding of what it does. And the book covers this fairly well. These two videos do a great job with some computer graphics of kind of taking you inside the brain and showing you the neurons, and showing you the dendrites and some of that. Okay, two things that are important to know about an agonist and an antagonist. So an agonist is a drug or poison that increases the activity of one or more neurotransmitter, right? So an agonist actually increases a neurotransmitter, one or more neurotransmitters, and an antagonist is a drug or poison that decreases one or more neurotransmitters. So in some situations, you can imagine that you would want more of a neurotransmitter. So adrenaline potentially, or something that's going to assist you with maybe memory recall or pain, right? Pain blockage, probably not pain itself, right? And an antagonist is something that's going to help block that. It's going to decrease the activity of the neurotransmitter. So if you're getting inundated with pain, then you might want to fill up your neurotransmitters so that you're not going to be receiving as much of the, actually that may be adrenaline too, that's coming from that. Okay. These are a couple of different ones, a couple of different neurotransmitters. Again, we're not going to go into all these, and for this class, it's not important that you know all of these. A couple of them are the heavy hitters, we would say. Serotonin, one people are usually very familiar with. Dopamine, something else people are usually very familiar with. And then endorphins. Something that's really cool about endorphins is that endorphins actually stands for endogenous morphine. So this is actually morphine that your body itself makes, which is very cool, and why it's very important in pain relief. And also sometimes people talk about your endorphin high or your endorphin rush when you're like running or doing something like that you might see as painful, but then you get this rush, right? And then all of a sudden you got these feelings of pleasure. Because your body is literally flooding yourself with this really awesome morphine. Okay, these are videos that you guys are gonna look at. These are just very cool videos, much cooler than anything I could stand and point to for you. A couple things we'll talk about really quick. The plasticity of the brain. 20 years ago or so, we thought that if something happened to the brain, that's it was done. It wasn't gonna change, nothing was gonna happen. Sorry man, you're just stuck. However, we've actually found that's not the case at all. The brain is really plastic. The brain is just amazing, just amazing. If that's one thing you get from this class, it should be the brain is amazing. And the plasticity really shows that our brain can rewire itself. So much so, there's one case of somebody who lost their hearing, and they actually were able to work with their brain so that a whole new part of their brain that doesn't even have anything to do with hearing learned to take over the role of hearing. right? I mean, what? Yeah, I mean, it doesn't, just, like, we're not lizards. We can't grow our tails back. Oh, wait, but can we? That's what we're kind of finding out with brain plasticity. All of our expectations and our preconceived ideas of what the brain can and can't do are just getting blown out of the water. It's an incredibly fascinating time to be in brain research. Okay. So this is just a fun little thing that I want to talk about a little bit. So the amygdala, we've all heard a lot about the amygdala. The amygdala is involved in fight, flight, freeze. It's really involved in our reactions to things, how we're going to respond to something. Well, the question is, what if your amygdala is really just not very responsive? What if you have like a very quiet amygdala that just doesn't get very upset about things very often? Right? Typically, if this happens, if people have very inactive amygdalas, we typically see that their behavior then becomes kind of self-destructive. That part of their brain that they feel excitement, they feel a rush, they feel on edge, oh no, something's going to get me. They don't really have that for normal things, so they usually go do extreme, dangerous behaviors in order to get their amygdala to give them some feedback. Oftentimes this might be extreme drug usage, very unsafe sexual practices, something that's going to get the amygdala to finally start making some noise. But there's an interesting case, and some of you may have seen the movie about this guy. There is this guy named Alex, and he has an amygdala that is not very active, and so he free climbs. Free climbing, so these pictures are exactly what it looks like. He is climbing these mountains with no crimps, what are those things called that go in the rocks? No ropes, no nothing. Like, he literally has a little bag of chalk and his hands, and then like cool little grippy shoes. That's it. And a couple years ago, I think maybe last year or the year before, he actually free solo climbed El Capitan. Crazy that he could do that. There's a video here, a video link for you to see. But this is an example. The reason he can do this is certainly he must have amazing physical prowess, and training and dedication. Yes, I'm not trying to at all take away from his personal attributes that have allowed him to do this and train up to this level. It's amazing. It's very impressive. We also need to acknowledge that his brain is actually different. So looking at him do some stuff and you go, ah! Just looking at him, that is because your amygdala is working. That is because your amygdala is ready for that information, that sensory input, and is responding. His amygdala, he's hanging out on this cliff of this mountain, and he's going, yeah, this is kind of cool. Right? Because his amygdala is so much quieter. Right? So he's able to do some things that most of us would just freak out about or have no interest in doing in the first place. Okay, so that is just a little bit about neuroscience, a little bit about the brain, the different parts of the brain, and how very awesome the brain is. Check out these links. They will be available in the PowerPoints, and then they will also be made available to you through the class. And let me know if you have any questions or comments, and I'll try to address it next week. Maybe we can talk on the phone or exchange emails. I love it when people are personally excited by this material, so please do not feel like I am inaccessible to you or unavailable to you. Have a great day.